Hey everyone, in this video we are going to be talking about multi-step conversions. So we've already looked at single step where we would go from moles to atoms, compounds, molecules, particles, or formula units. Or we may go from moles to grams and then vice versa. So we may go from grams to moles or atoms, compounds, molecules, particles, formula units to moles. Now we're going to look at, if we're given grams and we need to go all the way to atoms, compounds, molecules, particles, formula units, or the opposite. Okay, so we're still using this chart that we had made whenever we looked at our single step conversions. I'm not going to redraw it. I just put it here already. And then let's go ahead and get into some examples. So our first example is going to be how many atoms are in 12.3 grams of KF. Okay, now we are still using our guess method. So we're going to start out with our given, and this time they give us 12.3 grams of KF. Okay, then our unknown, or I like to think of the unknown as the thing I'm trying to get to. So in the end of this, I'm trying to get to atoms of KF. Now, this is where using my chart is going to come in very handy, because I know that I'm going to start with grams. And if I come up here, if I start with grams, I'm going to have to go to moles. And the way that I get from grams to moles is I have to divide by my molar mass. And remember, I write that below my arrow because I am going to be dividing. Then, once I'm in moles and I'm trying to go to atoms, I follow my arrow and I'm going to multiply by 6.02 times 10 raised to the 23rd. Okay? Now, we have to find the molar mass. So the molar mass of KF. And again, I'm not going to go through and show finding these masses on the periodic table. I'm just going to go through and find the molar mass here. 39.10, 10.00, and then we're going to get 39.10, 19.00, add them together, and we get 58.10 grams per mole. And I want you to remember that this right here means 58.10 grams equals 1 mole. So we're saying that a mole of KF is going to weigh 58.10 grams. Okay? Now we can go through and do our setup. And if you remember, every time that we do our setup, we always start with what we're given, which was the 12.3 grams. Okay, if I start with grams of KF on the top, grams of KF has to be on the bottom. And if I come up here and look at my path, I'm going to moles. So that means that the mole of KF is going to be on the top. Then, if mole of KF is on the top, mole of KF has to be on the bottom. And then what I'm trying to ultimately get to, which is in this case is going to be atoms. Will go on the top. Okay, and then we fill in. So the 1 will always go with the mole for what we're doing right now. 58.10 will go here, and then 6.02 times 10 raised to the 23rd will go here. Now, when you type this into your calculator, you need to use parentheses. So you need to type it in as 12.3 times 6.02 times 10 raised to the 23rd, parentheses, divided by 58.10. And the reason for that is if you don't do that, then your calculator gets confused and it thinks that you are multiplying. So, or dividing, either way, it gets confused with the exponents. And whenever we type this into our calculator, we end up getting 1.27 times 10 raised to the 23rd atoms of KF. Okay. And up here in my path, I wrote multiply by 6.02 times 10 to the 23rd. That is correct, but I'm trying to get to atoms up here. So then we'll multiply by 6.02 times 10 raised to the 23rd. Okay. Now, I want you to try this next one on your own. So this one is going to be how many molecules are present in 4.5 grams of H2O. Okay, so you pause this video and you work this one out on your own. Then come back and check your answer. Okay, so I trust that you have done that. So let's start out with our given. So this time they give us 4.5 grams of H2O. The unknown, or the thing that we're trying to get to, is going to be molecules of H2O. And then our path. So we're going to start out with grams. And our middleman, so to speak, is going to be moles. So we're going to start with grams and go to moles, which means that we have to divide by our molar mass. And then we're going to go to molecules. And if I come back up to my chart, if I'm going from moles to molecules, then I'm going to have to multiply by 6.02 times 10 raised to the 23rd. Which is Avogadro's number. Okay? Now, we have to find the molar mass of water. So, molar mass of H2O. And again, I'm not going to show on the periodic table finding the masses. I'm just going to work out the molar mass. So 18.02 grams per mole, which again, that's the same thing as saying 18.02 grams equals 1 mole. Okay? Now, it's time to do our setup. So, we always start with what we're given, which was 4.5 grams of H2O. If I start with grams of H2O on the top, That means that grams of H2O has to be on the bottom. And the thing that I'm trying to get to, which in this case is moles, is going to go on the top. Then if mole of H2O is on the top, mole of H2O has to be on the bottom. And what I'm trying to get to, which is molecules, will be on the top. And then we plug in our numbers. And again, for what we are doing right now, the 1 will always go with the mole. The number that you find in your molar mass will go with grams. And then 6.02 times 10 raised to the 23rd will always go with atoms, molecules, formula units, whatever. Okay? And then whenever you type this into your calculator and you round to 2 decimal places, you'll get 1.50 times 10 raised to the 23rd molecules of H2O. Okay, so again, about 1.50 times 10 raised to 23rd molecules of H2O would be your answer. Okay, then let's look at going the opposite direction. So both of these examples have been, well, if we start with grams and we're trying to go to something in green, the atoms, compounds, so on. Now let's look at the opposite. So for example number 3, how many grams, so how many grams are in 2.4 times 10 raised to the 24th formula units of CaCl2. So how many grams are in 2.4 times 10 raised to the 24th formula units of CaCl2? So again, we start out the exact same way. We find our given, which is the 2.4 times 10 raised to the 24th formula units. And be careful with how you try to abbreviate formula units. You could say form units if you want to, but just be careful with your abbreviation. And then our unknown, or the thing we're trying to get to, is grams. So grams of CaCl2. And then our path. How are we going to get there? So we're going to start with our formula units. Okay. So if I start with formula units, which is over here in the green, I follow my arrow and I'm going to go to moles. And the way that I do that is I divide by 6.02 times 10 raised to the 23rd. Okay, and then from moles, I can get to grams. And then if I scroll back up, the way that I do that is we're going to multiply by our molar mass. Okay, and remember, big M, little m is molar mass. So we're going to have to find the molar mass. So molar mass of CaCl2. So CaCl, we have 1, we have 2, 40.08, 35.45, and 70.90. Add them all together, 110.98 grams per mole of CaCl2. Okay, and again, what we're saying there is 110.98 grams equals 1 mole. Okay. Then we have our setup. So, in our setup, we always start with what we're given, which is the 2.4 times 10 raised to the 24th formula units. So 2.4 times 10 raised to the 24th formula units of CaCl2. If I start with formula units on the top, that means that formula units has to be on the bottom. And then what I'm trying to get to, which in this case is moles, will go on the top. Then if moles is on the top, moles has to go on the bottom. And then the last thing I'm trying to get to, which is grams, will go on the top. And then we fill in. So again, 1 will always go with a mole for what we're doing right now. 6.02 times 10 raised to the 23rd will go with the formula units. And then that number that we found for the molar mass, that will go with the grams. And then whenever I go through, I do the math, and I need to, especially here, make sure about the parentheses, because if I don't use parentheses where I'm dividing by the exponents, my calculator will think that I'm multiplying if I don't use the parentheses, and it will give me an exponent in the 40s. If you get an exponent in the 40s, you have messed up, and it's because of the way you've typed it in your calculator. So you need to type it like this. Divide it by, in parentheses, 6.02 times 10 raised to the 23rd. Okay? And whenever you do that and round to 2 decimal places, you should get 442.45 grams of CaCl2. Okay? Now, we've got one more example to do. And this one, we are going to be going from molecules to grams. So I want you to try this one on your own. So example number 4, how many grams are in 7.92 times 10 raised to the 24th molecules of magnesium hydroxide? So pause this video and go through and work this one out on your own. Okay, so I trust that you have taken the time and you have paused and worked this out, and now you're coming back to see if you were correct. So, in this one, you are given 7.92 times 10 raised to the 24th molecules of magnesium hydroxide. And then the unknown, or the thing that you're trying to get to, is going to be grams of magnesium hydroxide. Okay, and then our path. We start out with molecules. From there, if we start with molecules, we have to go to the mole. And whenever we do that, we're going to divide by 6.02 times 10 raised to the 23rd. Okay, and then from moles, we can get to grams. And the way that we do that, if I start with moles and I follow my arrow, is going to be to multiply by molar mass. So grams, and then multiply by molar mass. Now, if I'm going to have to multiply by molar mass, I have to find the molar mass. So, molar mass of MgOH2. So, magnesium, oxygen, hydrogen. You have 1. And don't forget here, you have to distribute that 2 to everything that is in the parentheses. So 24.30, 16.00, 1.01, 32, and then 2.02. Add those all together, and you get 58.32 grams per mole of magnesium hydroxide. Okay. And then we have our setup. So again, you always start with what you were given, which in this case is going to be 7.92 times 10 raised to the 24th molecules of MgOH2. If we start with molecules on the top, molecules has to be on the bottom. And the thing that we're trying to get to, which in this case is going to be moles, will go on the top. And then if mole is on the top, mole has to be on the bottom. And then the thing that we're trying to get to, which in this case is going to be grams, will go on the top. And then we plug in. So again, 1 will always go with the mole for what we're doing right now. 6.02 times 10 raised to the 23rd goes with the molecules. And then the number we found whenever we did the molar mass goes with the gram. And if you type this into your calculator, again, use parentheses and round to 2 decimal places, you should get 767.27 grams of magnesium hydroxide. Okay. And that is it for our multiple step conversions.